this video, I am still going over example number 1 of lesson 16. So, lesson 16 on function compositions. We're going over example number 1, but we're moving on to part C, and D. Okay. So, take a look at letter C. We are doing this. Let's define the function in the first table as D is equal to f of s, and the function in the second table as P is equal to G of D. Use function notation to represent each output and use appropriate tables to find its value. Use the appropriate table to find its value. So function notation is this notation here. Okay, so what does that notation mean? If you need a quick reminder, think back to your function notation. This is the function name. This is the input, so what we're putting in, and then what we're getting back out, so our output. And that makes sense in our first table, because if you go back and take a look at our first table here, our input, like what we're putting in to figure out our information, is that time of descent, and we've labeled that as S. And our depth of the diver is what we're getting back out. So that's what we're trying to figure out. So that is labeled D. So here we have our output D. D is equal to f of s. And f is that pattern, or that pattern that the table tells us. So it's our function name. So in essence, if this is our table, this is our input in, this is our output out, then our name of the function would be like f. Okay. And in the same way, we have P is equal to G of D. Go ahead and double check with the second table at this point, see if it makes sense to you. Pause the video if you need to. Okay, so this is where function notation comes into use, because instead of describing this in English, we can now write this in math notations. So if I'm trying to find the depth of a diver at 80 seconds, that means, how would you do this question? You would take a look at this graph. We're trying to find the depth of the diver at 80 seconds. Pause, think about how you would do this. And here we go. Okay, so we take a look at the seconds. We go to 80, and it looks like it corresponds with 65 meters in depth. So our answer is 65. But at the same time, how do you write this in function notation? Well, here's our notation. What we've done is we've taken the first chart, which is f, and we've plugged in 80 seconds, right, to get back our 65. So what the function notation is, this would be f of 80 seconds, and that is equal to 65 meters. And that is our function notation. Go ahead and try letter B on your own, and then we'll go over it. Okay, so the pressure of the diver at 60 meters. Now we're looking for pressure, so if you go ahead and look at your two functions, one gives you an output of depth, one gives you an output of pressure, so we need to use the second one, so we need to use this one. So now we have the function g, and we're going to plug in the depth of 60, and what we get back out is our pressure. So go back and look on that chart, but the pressure, I believe, is 7 atmospheres. And that is our function notation in a context. Okay. So this one I really want you guys to give it a try. So explain how we could determine the pressure applied to a diver after 20 seconds of descent. This is where function composition comes into play. Because composition is when we start putting things together, right? If you remember back to English, like a composition notebook, you're composing a bunch of sentences to create, say, a story, to create a sentence, to create a paragraph, to create an idea. So in this case, we're composing a bunch of functions into a bigger idea. So take a look at this question, try it out. The explanation will be on the next video.